All right, guys, this is 12.2 missing angles. So in our last lesson, we learned how to come up with the ratios for each type of trig function, whether it be sine, cosine, or tangent. And we used SOHCAHTOA. So sine of theta is opposite over hypotenuse, and then cosine of theta is adjacent over hypotenuse, and then tangent of theta is opposite over adjacent, okay? So today we're going to use that again, but we're going to actually solve for a missing angle. If we have the sides, we're going to figure out how to find those missing angles. All right, so let's do a quick review. If we're trying to solve for x, what would we do? And you might say, oh, we'd divide both sides by 2. Well, why do I divide? Okay, well, it's because we were multiplying. The opposite of multiplying, or the inverse of multiplication, is division. So we would divide both sides by 2, and we'd get x equals 2. Okay, same as b. How do we get x by itself? Well, we would subtract by 2. Why would we subtract? Because the opposite, or the inverse of addition, is subtraction. So we would get x equals 2. Or we could look at c. We have x divided by 2 equals 1. Well, how do we get x by itself? Well, it's being divided by 2, so its opposite would be to multiply both sides by 2. And we'd get, and those would cancel, and we'd get x equals 2. Okay, so we could do the same sort of thing. If we had x squared equals 4, well, how do we get rid of the exponent? What's the opposite of squaring? Well, the opposite of squaring is square rooting, and we would get x equals 2. Okay, so these are all these operations have what's called inverses. They're opposites. Opposite of addition is subtraction. Opposite of multiplication is division. The opposite of squaring is square rooting. Okay, and there's lots of different things. You can also do inverses of functions and things like that. So let's go back to what we did last time. Last time we found ratios. So what's the ratio for sine theta for this example? Well, what we did is we started with our reference angle. We labeled what H, O, and A are. And then sine, we said, is O over H. So it would be 12 over 20. And we would simplify that ratio. Okay? But today what we're going to do is we're going to try and solve for theta. Find that angle, that reference angle. Okay? So it's very similar to what we did before, above here, is we used inverses. Okay? So sine is a function. It's not something that it's not being multiplied by theta. We can't divide both sides by sine, but there is an inverse for sine of theta. Okay? So if you go to, let me see if I can get to this still. Okay? If you go to your calculator, and it will look a little different than mine, but the buttons are the same. Okay? If you look at this, you'll see buttons that are sine, cosine, and tangent. It's like right above the 7, 8, and 9. Okay? So you see sine, cosine, tangent. All right? If you look right above it, in mine it's blue. Okay? And I don't know, you might need to make your screen full screen or use your Chromebook to be able to see it because it's so small. But you'll see sin to the -1, cosine to the -1, and tangent to the -1. Those are the inverses. Those are the opposite of sine, cosine, and tangent. Okay? How you access that is using second sine or second cosine. So for this button, it's this blue button. If you're using a Casio like one of mine, it's the same sort of location. It's just shift. Okay, so do shift sine, shift cosine. So here if I did second sine, if you can see that, it brings up the sine to the -1. So that's the inverse sine. Okay, So that's where you locate that. All right, so if we want to get theta by itself, what we need to do is we need to use the sine inverse of both sides. Okay, just like here, we divided both sides by 2, both sides, or we subtracted both sides by 2, or we multiplied both sides by 2, or square rooted both sides by, or we square rooted both sides. Okay, same sort of thing. If you want to get theta by itself, you'll do sine inverse of both sides, and then the sine inverse and the sine will cancel out. So then we can just plug in, we'll have theta equals sine inverse of 12 over 20. So you'll type this part into your calculator. This you have to do using a calculator. You can't do it by hand, okay? So bring your calculator, borrow one of mine, okay? All right, so let's make sure that we're good with that. So everybody type that in. So we'll type in second or shift sine, and then we'll do 12 divided by, so you don't need to do a fraction, you can do division, so you can do sine 12 divided by, or sometimes your calculator will do 12 like that, divided by 20. Okay, all good. Don't need to use, like, make it look like a fraction, okay? So you do that, and I ended up getting 36.9 if I round to the ones place, okay? If you got something different than that, then that's okay. I'll walk you through why, okay? So you might have gotten 0.64 if you round to 2 decimal places. Okay, the reason why is this is in what's called degrees, and you've done everything so far in degrees. And this is a different unit called radians, and we are not using that for this unit. Okay, you'll learn that next year. Okay, so we need to make sure it's in degree mode. Okay, and how we do that is, if a lot of calculators will have a button that's like mode or setup, and you'll just need to go there. Like for mine, I would go here and I'd go to mode, and then I have the choice to choose radians or degrees. So I need to come down here to degrees, I'd push enter, and then I could go and do what I wanted. So sine inverse of, what was it, 15 divided by 20. No, that's not what it was. It was 12, sorry. So second sine inverse, 12 divided by 20, and it gave me that 36.9 that we were looking for. Okay. All right, so that is it. If you have questions on being able to put your calculator into degree mode, please let me know, and I'll help you out. Oftentimes you can also just Google the type of calculator you have and how to switch it into degree mode, and that will help. Okay, so these are those SOHCAHTOAs that we talked about. Okay, we're going to use those still. All right, so let's go into these problems. This is what we're going to run into. All right, so we have reference angle. We're still going to label our sides, so H, O, and A. But here we only have 2 sides that are given. Okay, I know we have a side that's missing. We're missing the hypotenuse, but we do not need to find that. What they're asking for is the reference angle, okay, for that theta. So we're given O, we're given A. We need to figure out which trig function uses O and A, all right? And the only one that uses O and A is tangent. So we would do tangent of theta is equal to O over A, which is 7.4. So we just basically substitute what we do know, and then we need to solve for theta. So we'd use tangent inverse, that cancels out, and we have our problem that we need to type in. So here we use our calculator, and we get theta equals, so we'll type in second or shift tangent to get tangent inverse, 9 divided by 7.4. And I got 50.6. I know it says here round to the hundreds, but we'll just do 1 decimal place. Okay. And that's an approximation. We had a round. Okay. All right, so let's try another one. We have a reference angle. This would be our H, O, and A. So what trig function uses A and H? Well, we look up here. A and H is adjacent over hypotenuse. That's cosine. So we do cosine of theta equals A. So that's 5 over H is 16. Okay, we need to get theta by itself, so we'd use cosine inverse of both sides. So we get theta equals cosine inverse, so we'll type that in, shift or second, cosine, get cosine inverse of 5 divided by 16. And I got 71.8 degrees. All right. Okay, we can skip C. Let's try D, because we haven't done this. We've done tangent, we've done cosine. Let's see if we can do D. So reference angle, we would have opposite, hypotenuse. This would be adjacent. So what uses O and H? Well, that's sine. So sine of theta equals 19 over 53. Again, we needed to get theta by itself, so we'd use sine inverse of both sides. And we'd get theta equals, sorry, I missed that little one. So second sine 19 divided by 53. And I got 21 degrees. Okay, so why don't you pause and give E and F a try? You can do C as well. Okay, and then that will be it for today. All right, hopefully you gave that a try. Here is our hypotenuse, opposite and adjacent. A and H uses cosine, that's our ca. So cosine of theta equals adjacent over hypotenuse. And then we use the inverse. So theta equals second cosine of 51 divided by 53. And I got 15.8 degrees. All right, next one, we've got hypotenuse, opposite and adjacent, opposite and adjacent. So what uses O and A? So ca, to, so tangent of theta equals O over A. And we'll use the inverse. And we get theta equals second tangent, 14 divided by 28. So I got 26.6 degrees. And then if you wanted to do this one, kind of skip that one, this would be HOA. So that uses cosine equals 20 over 24. We use our cosine inverse. And we would get theta equals second cosine. So for inverse, cosine inverse is 20 divided by 24. And I got 33.6 degrees. Okay? I think on your homework, they're going to ask you to round to 1 decimal place or the tenths place. So please do that. And again, if you have any questions, let me know. Make sure you check your odd answers to make sure your calculator is in the right mode. Your answers are looking good. And we'll see you later.